Example 15. A couple plans to have 3 children. Then how many arrangements we can think of? How many possible arrangements, right? So that means that is the sample space. So how do we write the sample space? So we can say first boy, second boy, third one also boy. Only boys here. Next boys, girl. Then B, G, B. B, G, G. Oh, first one girl, second one boy, next one also boy. G, B, G. G, G, B. Oh, all girls, no boys. So these are the all possible arrangements. Therefore, this is the sample space. First one, write down all 8 arrangements of sexes of 3 children. That is the one we have here already. What is the probability of any one of these arrangements? What is the probability of B, B, B? We have only one B, B, B. Therefore, 1 divided by total 8. 1, 8. Similarly, if you write all the elements, probabilities for all the elements, you see each of them has 1, 8. So let me write the last one, that is also 1, 8. So we can say these outcomes are equally likely. I explained equally likely one of my previous video under chapter 12. Let x be the number of girls the couple has. X is number of girls. Now understand the values of x. So here how many girls? Is 0. No girls. Here 1. Again 1. Here 2. Again 1. 2 girls. 2 and 3 girls here. Therefore, what are the value of x? 0, 1, 2, 3. Starting from your work in A, find the distribution of x. How do we find the distribution of x? We know we need x values 0, 1, 2, 3 and probabilities of those values, corresponding probabilities. So probability x equals 0. X equals 0 mean no girls. So how many we have x equals 0? No girls, only 1, right? That is the B, B, B. That is the x equals 0. So out of 8. Therefore we can write 1 out of 8. Probability here x equals 0 is 1, 8. Now probability x equal 1. That means 1 girl. How many we have with 1 girl? Here you see 1 girl, here 1 and here 1. We have 3 elements, right, with 1 girls or 3 sample points. Therefore 3 over 8. We can write 3 over 8. How about the x equal 2? That means 2 girls. Here 2 girls, here and here. Again, there are 3. Therefore, x equal 3. That is x equal 2. It is 3 over 8. So, probability is 3 over 8. And this is, you can see, only girl, only 1 over 8. Now, get the summation of these probabilities. You see that is 8 over 8, which is 1. Therefore, this is legitimate probability model. Then part 3. What is the probability that x equal 2? Probability x equal 2. You see this is the x equal 2. Then probability is 3 over 8. Example 16. A study of 12,000 able-bodied male students at the University of Illinois found that their times for the mile run were approximately normal with mean, right, times for the mile. Then we use y. y has normal distribution, mean is 7.11 and the standard deviation is 0.74. What type of random variable we have? Here y is a random variable. Y has a normal distribution. So normal distribution is always continuous. Therefore we can say y is a continuous random variable. And also y used for the times for the mile. Times is continuous. Therefore we can say y is continuous random variable. We can use both factors to decide the random variable. Right, first one, say in words what's the meaning of probability y greater than equal 8 is. So what is the probability? Y is the times for the mile. Therefore we can say probability of time for the mile at least 8 seconds. So you can write that event in your words, your own words. Then find the probability. Probability y greater than equal 8. We know this is normal distribution. Then we have greater than equal 8. So first step to write down this less than or equal 8, right? How do we write in less than or equal? 1 minus probability y less than or equal 8. So this is 1 minus, then what is the next step? Convert to the z. Z less than or equal, okay, how do we convert to the z? You know z equal x minus mu over sigma. What is the x? X is 8 minus 7.11, then sigma is 0.74. For the 3 decimals, I can say 1.203. Then I write with 2 decimals 1.20. Now we should use the z table to find the probability. It is 1.20, 1.2 is here, 0 is here, therefore number is 0.8849. Then 0.8849, 1091, 945, 981, 981. So answer is 0.1151. Second one, write the event. The student could run a mile in less than 6 minutes. Okay, less than 6 minutes. So how do we write this? Y less than 6. Okay, then how do we find the probability? Y less than 6. This equal, you know we already have less than. Therefore we can convert to the z value here. How do we convert to the z value? Z equal x minus mu over sigma. What is the x? X is 6 here minus mu. Mu is 7.11 and divided by 0.74. So this is negative 1.5. Therefore we can write here negative 1.5. Now we find the probability z less than negative 1.5. Here is the z table for the negative values. Negative 1.5. This one, and this is the 0 here. So number probability is 0.0668. 0.0668. Therefore this is the probability y less than 6. Now let me explain few things here. Here we write probability y greater than or equal 8 equal 1 minus probability y less than or equal 8. This is true for only continuous case. If we write this for the discrete case, suppose this is the discrete case, right? So then this should be y greater than or equal 8. This equal 1 minus probability y less than 8. So then 1 minus probability y less than or equal 7, right? Then how do we find this probability? If this y goes from 0 to 10 or some other numbers, so I say y, we write the probability y equals 0 plus so on up to probability y equals 7. Then we add these probabilities and subtract from 1. That is the discrete case. But this is continuous case, so this is true for the continuous case only. Example 17. If the height x of the woman we choose has the normal distribution, right? I use x, then normal distribution 64.3 and 2.7. What is the probability that a randomly chosen young woman has height between 68 and 70 inches? What is the random variable here? It is x. X is the continuous. Why? We use x for the height, right? Height is continuous. Or x has the normal distribution. Definitely, normal distribution is the continuous distribution. Therefore, x is the continuous random variable. Asking probability x between 68 and 70. So what is the first step? First step to split this, right? How do we separate this one? First we go with the big number. So probability x less than 70. You can use less than or equal because of continuous. Here again always we use the big number first, okay? As an example, I can say probability A, X, B. This always probability x less than equal B minus probability x less than equal A. That is chapter 3. So this one we can write probability x less than or equal 7, then minus probability x less than or equal 68. Then what is the next step? Next step is to convert to the z, because both cases use z less than or equal. Therefore, we don't have to worry. We can convert to the z. Probability z, how do we convert to the z? Z equal x minus mu over sigma. For first one, z equal x is 70 minus 64.3 divided by 2.7. So that is 2.111. So for the two decimals, I write 2.11. Next one, probability z less than or equal. Here z equals 68 minus 64.3 divided by 2.7. That is 1.370. I write here 1.37. Then we need to find the probabilities using the z table. First 2.11. First 2.11. 2.1 is here and 1 is here, and this is 0.9826. So this probability 0.9826 minus next probability z less than or equal 1.37. So 1.37, this is 1.3, this is 7. So number is 0.9147. 0.9147. So answer is 679, then 7, 716, 990. That is 0.0679. That is the probability between 68 and 70.